Welcome to the DESI ASTRO. In this Python tutorial, we will be learning that how to fit a multi-peak Gaussian on a scatter plot using NumPy, Scipy, and Matplotlib library. So here you can see that the Gaussian function. So 1 by sigma root 2 pi. Basically, it is the amplitude, and this part is mu is mean, and sigma is the standard deviation of the distribution, right? So here I have a simple plot. You can see here the red see that here the red dots are your data points, and it represents distribution of Gaussians having two peaks, and your blue line is the fitted Gaussian around these peaks. So what we have to do, we have to find this amplitude, the mean, and the sigma of these lines via fitting. So let's do it. Alright, so for doing that, first of all I will import libraries which will be needed to do this stuff. So first step is to import a library. So I will import numpy as np. So import numpy as np, right? And then I will create data points, right? So create data points. So I can create my x-axis. So np dot linear space. So I can go from -10 to 10, and I can give 100 data points, right? Then I can define my y. Okay, so y. So suppose like I want to define my y as a y1 plus y2. Okay, so for 2 Gaussian, right? So I can define here y equal to, say, I can give this distribution. So suppose I want to give amplitude as a 100 into then np dot exponential, and then I can give minus, I can give, say, x minus 0 whole square divided by, say, I can give say 1, right? And then I can define one more. Say I can give here, say 50 into np. There is some mistake here. So there is this np dot exponential minus, say I want exponential minus I want mean equal to 5 and square divided by 2, right? So this is my simple plot, and I can plot it. So for plotting, you can import Matplotlib library. So import Matplotlib dot pyplot as plt. So this is for your visualizing the plots, right? Then you can plot. So type here plt dot scatter x comma y, right? So here you can see that, and you can also type here plt dot so, right? So this becomes your data points, right? So what we have to do, we have to like fit these peaks with Gaussian, okay, Gaussian profile. Okay, so you can do one more thing. You can add some noise. So you can add here noise to make this plot as a more scattered. So you can import your random module. So import random, then you can add here np dot random dot rand int, and then 0 to 5, and you can give say same number of data. Okay, so x dot size, right? Now plot it. So you can see this time your data points are a little bit scattered, so we have to fit to pick Gaussian through these data points. Okay, so for fitting I will import Scipy library. So from Scipy dot optimize import curve fit, right? And then I will define my define my function as to pick Gaussian, right? So for that I will define here function define say multi-Gaussian, right? And it can take parameters as x, you can take amplitude 1, you can take mean, and you can take deviation 1. Okay, it can take second amplitude, second mean, and it can take third standard deviation, right? Then you need to return the function. So type here return, and then you want to return your to Gaussian. So you can give here say a1 into np dot exponential minus x minus m square by 2, or you can just put half here if you want here, or yeah, just fine, into 2 into your s1 so you have to basically this function 2 into sigma square, right? So two into s1 square, right? Then you need to add one more function. So just copy this and paste it and make here a2, right? a2, then here should be m1, here should be m2, and here should be s2, right? And close this in a single, right? Now I will fit. Okay, so for that do fitting, right? So for that I will recall here POPT. So it stands for optimized parameters, and P covariance for finding the error in the fitting, right? Then you can call the function curve fit, and you can give here say Multi-Gaussian, and then you can give here x, you can give here y, and you can give here p0, right? So p0 is your initial value, So I can give P0 equal to P, and then I can give my P equal to, I can give a list, say I want to give my, say I want to give 91, 90, then 0, I can give 1, or I can give 40, then I can give 2, I can give 1. Okay, so this is like my initial guess. Initial guess to fit, right? Then I can pass these parameters here, right? Now run the code. What is mistake? S2 is not defined. Okay, there should be S2, not S3. Now fine, okay. So if you type here POPT, then you can see these are the parameters, and if you type here peak covariance, you can see this is a 6 cross 6 matrix, right? So now plot it, okay. So plot fitted curve. So for that you can define your model. So you can give your y fit equal to Multi-Gaussian x, and you can give a star and then POPT to evaluate on the all parameters, right? Then you can plot it. So type here PLT dot plot x and y fit, right? Now run the code. So here you can see that your data has been fitted with two component Gaussian, right? So I can give some, so go here and I can give some size s equal to 50, and you can give say color equal to red here, and then you can give here say line width equal to 5, and you can give color equal to k. Now run it. So maybe you can make it 100. Okay, so here you can see that your red points are data and black one is your fitted two component Gaussian. So you can also label this. So label equal to let's call it Multi-Gaussian fit, and you can label it as data, okay, and then you can give PLT dot legend, and here your job is done. Okay, so this is how we can fit a two component Gaussian on through the scatter plot. Okay, so here is the parameters. So this is amplitude 1, this is a mean, this is deviation, the second amplitude, the second mean, and the standard deviation, right? So similarly you can this the covariance matrix, and from there you can like find the error. Thank you. This is the plot, final plot, and here is the code. So you can review the code once again. So I have libraries, I have X data, I have two Gaussian with noise, then I have defined two function Gaussian combined, then I have fitted the curve with Scipy curve fit, I have given the initial parameters, then I have simply plotted this plot. So I hope you got the idea that how to do this multi-component Gaussian fitting. Thank you.